may wonder what we're looking at. This is a sleeping brain. It's not a starry sky. Every star depicted a neuron in sleep. So you might have wondered, is the brain switched off during sleep? It's not really. We've been investigating the sleeping brain, and I'd like to introduce you to the sleeping brain in this talk that I prepared with an amazing group of colleagues at the Netherlands Institute for Neuroscience. And I dedicate this talk to all insomniacs. And I'm sure that 1 out of 10 here in the audience are insomniacs. You might have seen that the baby showed facial expressions of things going on in the brain. But the thing we really want to know is, why is it that some people experience nice sleep and other people are light sleepers, awoken by whatever happens in the environment? What I showed you in the beginning, that activity of these stars depicting neurons and the trace, as you can measure with the EEG. Measuring neurons in humans is very difficult. We cannot go into the brain with our electrodes to get signals of these stars. So what we usually do is record a signal from the outside of the brain, as shown in the back. And if you look at the trace on the right and you go from top to bottom, you see what happens with this signal if you go from superficial sleep and wakefulness to deeper and deeper sleep. Now, what determines how deep we sleep? There are two signals by which we can measure if someone is a light sleeper or a deep sleeper. In blue, you see something we call sleep spindles, and people with a lot of sleep spindles are very hard to wake up by external stimuli. And in red, you see slow waves, these very slow, nice waves that signal whether someone is in deep sleep. So what determines in the brain whether people are deep sleepers or light sleepers? We measured this signal in many people and quantified their slow waves and the sleep spindles. And then we used MRI to look at the structure of the brain. And what you see here on the right is that there are several highways in the brain connecting brain areas, making fast connections between different brain areas. And what you see in the scatter plot, as we call it, in the middle behind me, on the horizontal axis, you see how strong the highways are in a specific subject. And vertically, you see in red, for every dot, which is a single person, how strong slow waves are and how strong spindles are. And there's a clear-cut relationship. The ones that have the better highways are the ones that have the deeper sleep. Now the question is, does that tell all? This is measured in relatively good sleepers. But what happens with people with insomnia? About 10% of us suffers from insomnia. So you have poor sleep at least 3 times a week. That can last for a month or 3 months repeatedly, and you feel lousy during the day, really lousy. Maybe in these people other things are going on. And as shown here in this fairy tale of Hans Christian Andersen, for this princess, there was something going on. She was very sensitive, even to a pea hidden under a layer of mattresses. That kept her out of sleep. Before heading to what we find in the brain of insomniacs, I would first like to give the floor to Alan Berliner, who is a documentary maker and an insomniac. And he explains what's going on in the mind of an insomniac. And let me give the floor to him. He's in dialogue with his psychiatrist, discussing how it should be to fall asleep, starting with counting sheep. And let's see if that really works.
7.
So whether it's just the numbers or whether there's an image associated with it,
11.
you're focusing
12,
on something particular.
55. Why sheep? 56.
I don't know where the sheep came from, but you know what?
110.
If something else works for you,
111,
that's good too.
112. 142, 143, 144, 173, 174, 175, 176, 225, 226, 227, 289, 290. Some nights when I hit the pillow, 290. All I hear is pounding. 93. Sometimes it feels like there's a woodpecker under my pillow.
Well, that's cool. It's not so cool. It drives me crazy. You know what that is? The carotid artery is just real near the ear there. And that's all you're doing is you're hearing your own pulse. It's very, very normal. It's not abnormal.
Well, why don't you hear your carotid artery?
I do. I just don't pay attention to it.
How long should it take me to fall asleep, ideally?
Most people fall asleep in 15 minutes or less.
And what should be going through my mind when my head hits the pillow?
That you love the way that pillow feels. That you love the way that bed feels. That you've never felt more comfortable in your life. And the next thing is nothing.
So if we listen to Alan Berliner talking about his sleep, he apparently doesn't seem to know that there could be something very comfortable and then slipping into nothing. And you might also have noticed that the guy lies awake listening to the pulse of his own carotid artery, like the princess on the P, lying awake of a very small, discomforting thing. So let's turn to the brain of an insomniac. In neuroscience, we want to know more than only complaints. On the lower side, you see the word complain. We want to know how these complaints come about by activation of the brain. And activation of the brain can only take place because there is structure in the brain, and the brain is built up from local networks of neurons, and they are built up of proteins, and how these proteins are built is all coded in our DNA. We want to go from what we call phenotype, this is just the complaints, to genotype and understand everything of that, especially if a complaint is heritable. And we know that insomnia is heritable. So let's try to go up one step on that ladder to see if we can understand what goes on in the brain. And this actually is a quiz. It's a quiz about twin research. Twins are very handy to investigate whether something is heritable or not. And what I show you here is EEG patterns. So 20 seconds recordings of EEG in twin sisters. And to make it a quiz, I scrambled the sequence of these EEG patterns. So on the left you see 4 different twin sisters, the left side of them, and on the right, in a scrambled sequence, the EEG pattern that belongs to the other one. And now I wonder, and I'd really like to know and see if you can participate. So we have that trace A, the upper trace, upper left trace of the left girl, and I ask you, what is the EEG trace of her twin sister on the right? Is that trace E or trace F? And please raise your hands if you think it is that trace. Or is it trace G? Or is it trace H? Wow. You're all scientists. So it's that easy to be a scientist. Okay? So here they're grouped together, and without doing difficult math or whatever, you see that the EEG is very much genetically determined. Another way to investigate activation of the brain is to play around with it. We can give the brain a magnetic stimulus. And if we do so over a part of the motor cortex that drives our muscles, we give a pulse there, and a few milliseconds later we can measure a response by a twitch at the thumb. And if we do so in insomniacs, the same magnetic pulse elicits a huge response. So it seems as if the brain is too sensitive, and we have here a measure that is very heritable, and even a slight increase in stimulus strength gives a huge increase in response of the brain. The brain is too responsive, is too excited. Another way to activate the brain, and you all know that, is just to do a task, to think of something. And we can ask people, for example, to solve problems. And if we ask these people to do so in the scanner, we can investigate where in the brain there's activation. And we notice that in insomniacs, there is a small part of the brain, but it's an important part of the brain. We call it the caudate nucleus, but you can forget it immediately. That doesn't activate enough while solving problems. And why is that important? We know that this is an area that acts as a brake in a car to stop things down, to slow things down. It seems as if the brake of insomniacs is not working well. We can try to go up one step more on this ladder of activation to structure to DNA and use MRI again to look at brain structure. And there we find in insomniacs that there is another area where there is very little gray matter. That's an important part of the brain where there are a lot of neurons doing the calculations in the brain. Insomniacs have relatively little gray matter in the frontal part of the brain, above the orbits of the eyes, that's essential for sensing comfort. Remember what the insomniac said in the movie? He had to be told that it could be comfortable in this bed. So just suppose that there is an area that senses whether everything is nice and smooth and warm and relaxed, and it is a sort of signal. It can give green light to the rest of the brain that it can stop monitoring the environment or taking action and just go on with the next thing, which is nothing. Falling asleep. But now comes the tricky part of my story. I told you about a few brain areas that determine sleep depth in healthy controls, in healthy people. A few brain areas that are involved in insomniacs. But poor sleep is also present in people with psychiatric disorders. And if you look at what determines the severity of insomnia in people with depression, much to our surprise, we find completely different brain areas involved. There's a part in the middle of the brain that connects a lot of brain areas where there is very little gray matter in those depressed people that really suffer from insomnia. And if we go to another group of psychiatric patients, people with anxiety disorder, again to our surprise, there's a completely different area involved in their insomnia complaints. So how should we go about with all this? It seems as if there is no such thing as one brain structure that is causing insomnia. It all may depend on other things, like whether you tend to be depressed or not, or anxious or not, or maybe whether depending on your personality. And we started an endeavor, and we need your help. We need everyone's help to try to solve this problem of insomnia. We started a website where people can donate information, nothing else, no money involved. They can just tell about their personality, whether they're easily stressed, whether they sleep well or whether they sleep poor. And it's not the idea to give an average profile of your typical insomniacs is so-and-so depressed and so-and-so anxious and so-and-so neurotic. No. Many people have tried that, and we don't get any further doing that. What we need is to leave that approach. What we need is to find different profiles of people with insomnia. And you can help by donating your information, giving information, but just filling in questionnaires on sleep registry. If we get these different profiles, then we can start doing the whole trick of looking into brain activation and brain structure, maybe even going up to the DNA, to finally understand what goes on in the brain of insomniacs and how we may help them. There is no one type of insomnia. There may be many types of insomnia. In my final slide, I would like to ask the question, why is lying awake during the night so robustly represented among us? So there are many brain areas that can cause insomnia. There are so many people that have insomnia. Why would that be? And maybe for that answer we have to go back very long in time. In primitive cultures, sleep is very different than sleep as you normally do. You would probably like to sleep in a dark room with fresh air, isolated. In primitive cultures, people slept all together near a fire. And the fire was good to keep the ferocious carnivores away. The fire was also good because it produced smoke to keep the insects away. So while people were sleeping next to the fire, of course a few had to be awake to keep the fire going. Now who were these people that kept the fire going and were wide awake with even a slight crack of dead wood? Just imagine that it might have been profitable for the survival of our species to have people around that are so sensitive to environmental stimuli and are so easily kept awake during the night. So we should not ignore insomniacs. Maybe insomniacs are just the descendants of the gods of our species. Thank you very much.